Hello, Mrs. Allison here, and today's lesson we're going to look at transformations. Now, you've actually studied transformations back in Algebra 1 and Geometry, but this year we're actually going to look at transformations across a bunch of different functions. But today our focus is just going to be on the y values and how transformations can affect our y values of any generic function. But before we do that, let's look at Desmos. Now, you've already done an activity using Desmos, so let's kind of look at two different things that can affect your y values. So the first thing that's going to affect our y values, now let's say this is our parent function. Okay, this is an absolute value function, but really this can apply to any function. Okay, so the first one that can affect your parent function is this a value. So let's take a look here at a, and let's see what it does. So from the activity, you should have noticed that anything in front of your parent function is going to affect a vertical stretch or compression. So here, if we take a look, when a is 1, well, we're not stretching or compressing it. It is our parent function. But as soon as we make a greater than 1, notice I'm now making my graph skinnier or vertically stretching my graph. And the larger the value, the larger you're stretching it. Okay, now let's see when a is less than 1. And when I mean less than 1, I mean anything between 0 and 1. We'll talk about what happens when it's negative eventually, but we're looking at just some number between 0 and 1. So now what happens is it gets wider, or I vertically compress my graph. So when a is between 0 and 1, it's going to vertically compress. And when a is greater than 1, it's going to vertically stretch. So that's the first one we're going to look at today. And then we have our k value. Okay, when we have a k value, when it's at 0, well, it is your parent function. But then as soon as I make k greater than 0, it's going to shift your graph up. And the larger the k value, the more it's going to shift it up. When k is less than 0, it's going to shift your graph down. And the further negative it is, the further it's going to shift it down. So those are the two transformations we're going to look at today. Okay, so here's your general formula. Now, as we go throughout this course, we're actually going to change that f of x, or that parent function, and replace it with the actual parent function. But because we haven't studied any functions yet, we're just going to use a general formula and call f of x any parent function, and g of x is our transformed function. Okay, now today our focus is going to be on a and k, and then eventually we'll focus on b and h. So a does a reflection, which we'll study later, but today we're going to look at vertical stretch or compression, and then k does a shift up or down. So today we're going to look at our parent function. Now, as I said, we can really use this function for transformations on any function, but we're going to look at just one specific function today. Okay, and we're going to call that function f of x. So this blue graph is going to be our parent function today. But I can really apply transformations to any function I want, but we're going to stick to one function today. So here's the points that go with that function. And this is going to be very important because those points we'll need in order to do our transformations. So first we're going to look at a. Okay, as we remember, a does a vertical stretch or vertical compression. So here's my parent function, and here's its points. So my first function, transformed function, has a 2 in front. So if we remember from our Desmos activity, when there's a 2 in front, so when a is greater than 1, we're vertically stretching by 2, which means I'm going to multiply my y values by 2. Okay, that's also known as your coordinate rule. Your x's stay the same, and your y's are going to multiply by 2. That will stretch them by 2. So I'm going to take these points here from my parent function over here in the right corner, and I'm going to multiply my y's by 2, and my x's will stay the same. Once I graph those points at -8, -6, -6, 4, -4, -10, 1, 10, and 3, 0, I now get a vertically stretched graph, as you can see on my graph there in red. Okay, now our new function is going to have a 1/2 in front. So remember from our Desmos activity at the very beginning here, whenever a is less than, so between 0 and 1, That means you're vertically compressing. And notice I say I'm vertically compressing by 2. The reason why I say it like that is because really compression means divide. So I'm dividing by 2 or multiplying by a half, however you want to view that. So my coordinate rule, my x's will stay the same, and my y's will be either multiplied by a half or divided by 2. So I'm going to take my points to my parent here, so up in the right corner here, those blue points still, and my x's will stay the same, and I'll divide my y's by 2. And I now get those points there. So when I plot them, I get this graph here in green. Notice the difference between my parent function and my transformed function. Okay, so with a values, such as 2.5, you're always multiplying your graph. That's going to stretch it or compress it. Okay, our other transformation is our k value. So remember, k shifts up or down. So here's my parent points in my graph again. So my first transformation function is going to have a plus 2 at the end. Whenever I have a plus 2, that means I'm shifting up 2. In order to shift my graph up 2, my x's are going to stay the same from my parent over here in the corner, but my y's, I'm going to add 2 to them. Okay, so I'm going to take these points and add 2 to my y's, and it's going to give me those points there. Notice I'm now adding 2 instead of multiplying by 2. Adding 2 will then shift your graph up rather than stretching it. Okay, so when I add 2 and I plot my points, there's my new graph in red that's been shifted above the blue original graph. Okay, and now if I have minus 2, that's going to shift my graph down 2. So I'm going to take my points to my parent up here in the corner, and I'm going to subtract 2 from my y values, giving me those points there. Notice my x's are still the same. It's my y's that have been subtracted 2 from. Okay, and notice I'm subtracting by 2. That'll shift them down, and there's my new graph shifted 2 units below the original. So A, you're going to multiply your y's by that value. That'll stretch them or compress them. Whereas K, you're adding or subtracting. That'll shift it up or down. Okay, now we're going to actually look at, given a function, we're going to describe in words the transformations. So if here's my first function, that 1/4 in front represents your A value, and because it's less than 1, that's going to be a vertical compression by 4. And that minus 6 will be a shift down 6. Okay, for this next example here, that 8 is going to be my K value, and it's positive, so I'm going to shift up 8. Okay, this next example is slightly different than the first one. Notice I have a 4 in front now, so that's going to be a vertical stretch by 4 because A is greater than 1, and a shift down 5. And then the last one here, that 3 in front, because A is greater than 1, I'm going to vertically stretch by 3, and I'm going to shift down 9. Okay, last thing is we're going to work backwards. So I'm going to give you the transformations, and you're going to write the function. So here in this first one, I'm going to vertically stretch by a factor of 5. That 5 represents your A value, so that should go in front of f of x. And then I want to shift down 3, that would be your K value. So your function's going to look like that. Remember, g of x is your transformation function, f of x is your parent, so the 5 is going to go in front, and the minus 3 goes behind. Okay, last example here, I want a vertical compression by a factor of 3, followed by a shift up 2. So remember, if I'm compressing by 3, that means I should have a 1/3 in front of f of x, and then up 2 would be a plus 2. So your function should look like that. 1/3 f of x, that's going to compress it by 3, and then up 2 would be plus 2. Okay, you are now done with transformations of y values, so you can go ahead and complete the Schoology assignment on transformations. Thank you.